lesson is on polygons, and in this lesson we're going to talk about different ways that we can classify and name polygons. So let's first start talking about what a polygon is. A polygon is a closed figure that is formed by a finite number of coplanar segments called sides. Okay? So when we say that it's a closed figure, it means that all of these line segments are going to have endpoints that connect with one another. So it's going to be a closed shape. And when we say that it has a finite number of coplanar segments, all right, it says that we have a certain number of segments that we can count. It's not an infinite number of sides that all lie on the same plane. All right. Now, what's also true about these sides is that the sides are going to have a common endpoints, all right, that are non-collinear. Okay. So all of the common endpoints of these sides are going to be on the same plane, but they're not going to be all on the same line. And each side is going to intersect two other sides, but only at their endpoints. So if we look at this polygon here, we have 1, 2, 3, 4, 5, 6 sides, and each of those sides, all right, we see this side here intersects these two sides, and they intersect them at their endpoints. Okay, we see that when we have these line segments, all right, we have all of these different angles that are formed here. And the vertex of each of those angles that are formed is also called the vertex of the polygon. All right, so at each of those endpoints, okay, we call those endpoints the vertices of the polygon. Okay. Now, let's talk about different ways and different classifications that we can have for polygons. All right, this polygon right here is an example of what's called a convex polygon. So a polygon is convex when there's no line that contains a side of the polygon, when no line that contains a side of the polygon contains a point in the interior of the polygon. And what that means is if I were to extend each of these sides here, okay, none of these lines are ever going to intersect in the interior of the polygon. All right, they all intersect in the exterior or outside of the polygon. All right, if this happens where none of these intersections are inside the polygon, it is convex. If a polygon is not convex, it's concave. All right, so a concave polygon is a polygon that is not convex. And an example of that would be if I had a polygon that looked like this. Okay, if I were to extend each of those lines, I see that some of these lines do fall in the interior of my polygon. Here was my polygon. All right, and some of those lines do go through the interior of the polygon. Okay, so that's what makes this concave. Right, so it's either convex or concave. Right, now some special types of polygons. An equilateral polygon is where all sides are congruent. Okay, so if I think of something like a rhombus, all right, a rhombus has sides that are all congruent, so that would be an equilateral polygon. All right. A polygon is going to be equiangular if all of the angles are congruent. All right, so if I think of an equiangular triangle, each of those angles is going to be congruent. And then a regular polygon is when all of the sides and angles are congruent. So all sides and angles are congruent. So in that case, a regular polygon is going to be an equilateral polygon and an equiangular polygon. Okay, so if you think of a square, all of the sides are congruent and all of the angles are congruent. All right. If a polygon is not a regular polygon, then it is an irregular polygon. So that is a polygon that is not regular. Okay. So if a polygon is equilateral, like this rhombus here, all right, but a rhombus is not equiangular, these angles are all not congruent, we would still say that it's an irregular polygon. Okay, and then the other way that we can classify polygons is typically how we name them, which is by their sides, the number of sides that they have. So a polygon with 3 sides is called a triangle. If we have 4 sides, that's a quadrilateral. 5 sides is a pentagon. 6 sides is a hexagon. 7 sides is called a heptagon. 8 sides is an octagon. 9 sides is a nonagon. 10 sides is a decagon. 11 sides is a hendecagon. And then 12 sides is a dodecagon. Now, after 12 sides, what we typically do is we stop using the formal name and we would say it's a 13agon or a 14agon or a 15agon, or if it had 32 sides, we would say it's a 32agon, just because it's hard to remember all of the names. So typically we only do names up until 12, and then that's when we start saying a 13, a 14, a 15agon, and so on. Okay, so we just went over a lot of different vocab terms. All right, now we're going to practice applying them. So for each of these problems, all right, we're going to do the same thing. We're going to classify the polygon by the number of sides. So we're going to name that polygon, and then we're going to determine if it's concave, convex, equilateral, equiangular, regular, and irregular. Now, when you're classifying these, you have to make sure that you're using the labels that are in the diagram. You can't assume anything unless it is marked off. Okay, so for the first one, all right, classifying this polygon by its name. All right, that's when we're going to use the 3 sides. So we have a triangle. All right, we have 1, 2, 3 sides. So this is a triangle. Okay. If I were to extend all of these sides, they're never going to intersect inside that triangle. All right, so we would say this is convex. Now the markings do tell us that it's equilateral. We have those tick marks there. It also tells us it's equiangular, which means that this is going to be a regular polygon. Okay. Number 2, if we wanted to name this polygon by the number of sides, we're going to count 1. I'm going to start here. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so 9 sides means this is a nonagon. All right, if I extend each of these sides, none of them are going to intersect inside that nonagon, so this is convex. All right, now I don't know that this is equilateral in my diagram, but I do see that it's equiangular. All right, that is marked off for me. So this is going to be a irregular shape just because we don't see that all of the sides are marked. Okay. Number 3, we have this arrow. All right, so I'm going to count my sides. I have 1, 2, 3, 4, 5, 6, 7. So this is a heptagon. Right. Now, if I extended these sides, all right away, I see that this side is going to go through my heptagon, this arrow here. All right, so this would be concave. I don't see any markings that would let me know that this is equilateral or equiangular, so this is an irregular figure. Okay. Number 4, all right, we have 1, 2, 3, 4, 5 sides. So this is a pentagon. Okay, I extend my sides. None of them are going to intersect inside the pentagon, so this is convex. And I don't have any markings that would tell me this is equilateral or equiangular, so this is irregular. Okay. Now, number 5, right, we have 4 sides, so this is a quadrilateral. All right. This is going to be convex. All right, none of those sides intersect inside this square. It's equilateral because all of my sides are congruent, all of my angles are congruent. So we have an equilateral and an equiangular polygon, which means it's also regular. Right. Number 6 is a hexagon, right? So if I start counting, I have 1, 2, 3, 4, 5, 6. All right, now if I extend any of those lines, right, it starts off looking like it might be convex, but once I get to this, whoops, that's pretty far off. Once I get to this segment here, I see it goes inside. So this is going to be concave. I don't have any markings that would tell me this is equilateral or equiangular, so we have an irregular shape, an irregular polygon. Okay, now number 7 we actually talked about. This is a quadrilateral. We have 4 sides. And our 4 sides are congruent. All right, so right away I see that this is equilateral. This is going to be convex. All right, none of those sides intersect inside. And this is irregular because we don't know, there's no markings that tell us that our angles are congruent. Okay. And finally for number 8, if I start counting up here, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 sides. So this is going to be a dodecagon. All right. This is going to be concave. This one's a little easy to see that our sides are going to intersect. Or if I extend those sides, they are going to go inside that polygon. I know this is equilateral. All right, I don't have any indication that this is equiangular, so this is going to be an irregular polygon. Okay? And that's pretty much it for just classifying and naming polygons. If you have any questions, you can comment below. Thank you so much for watching.